f of x equals minus 0.2x times x minus b. X is between 0 and b inclusive. This is a probability distribution function. We need to find b for part A, we need to find the mean for part B, and we need to find the variance for part C. So firstly, for a probability distribution function, you know that the sum between b and a, so the integral between b and a of f of x dx, you know that equals 1 because all the area under the curve represents the total probability. So it's like if the area's over the whole domain anyway, it represents the total probability, which must be 1 because that represents all possible outcomes. Right, so that means for our particular thing, we have the b is actually b, a is 0, of f of x dx is minus 0.2x x minus b, and we know that that equals 1. So we're going to go ahead and do the integral. We'll see how far we get. This is the whole thing. It is a calculator question. I'll certainly be using it later, but we'll just see how this one goes. So the easiest way to integrate this is to expand that bracket. So this is the integral between b and 0 of minus 0.2x squared plus 0.2 bx equals 1. Right, so the antiderivative function is going to be 0.2 minus 0.2 x cubed over 3 minus 0.2 x cubed over 3 plus, well, this is going to be 0.2 bx squared over 2. So you go 0.2 over 2 is 0.1. Plus 0.1, and it was bx squared. Evaluated at b and 0, and we know that equals 1. Remember, this was 0.2 bx squared over 2, so 0.2 over 2. Right, so if we were to then substitute b into this, substitute 0 into this and take 1 away from the other, the 0 bit would just give us 0 anyway, because minus 0.2 times 0 cubed. Well, 0 cubed is 0 and 0 squared is 0. 0, 0. We just need to consider b. So minus 0.2 b cubed over 3 plus 0.1 b times b squared is b cubed again, and that equals 1. So if you've got an equation like this, this 3 is a problem, so if we multiplied by 3 we'd get rid of that, but also the 10, the fact that it's in tenths is a bit messy as well. So if we just kind of multiply through by 3 and by 10, you're timesing by 30, but it's probably easier to think of it as times 3 times 10. So if we multiply this term by 3, it would be minus 0.2 b squared, b cubed, sorry. Then if we multiply by 10, that will be minus 2 b cubed plus, so if we multiply, it's probably easy to do this by 10 by 3, so times 10 is 1b cubed, times 3 is 3b cubed, equals, and 1 times 30. Okay, so minus 2b cubed plus 3b cubed is just b cubed. B cubed equals 30, so that must mean b equals the cube root of 30, and I can't see any advantage in turning that into a decimal at the moment, so I'm just going to leave it, especially when you think what we're going to use it for. It's part B. We need to find the mean, and you should know that mean equals the integral from b to a of x times f of x dx. That's just a standard formula for a PDF. Right, so our b, remember, was b, but now we know that it's the cube root of 30 and a is 0, so it's the integral between the cube root of 30 and 0 of, well, it's x times f of x was minus 0.2x times, it was x minus b, so that must be x minus the cube root of 30. X minus the cube root of 30. all of that dx. So we need to work that out, and actually that's quite messy, but to calculate the question, I'm going to do nearly all of it in the calculator, but I think I'll just tidy this up a little bit. So that's going to be the integral from the cube root of 30 to 0 of, so this is x times minus 0.2x, so that must be minus 0.2 x squared times x minus the cube root of 30 dx. I'm not going to do anything else with that. I'm going to go to the calculator, and it should be fine, because the luxury of this being a PDF means that you're not going to have any negative area problems, which is quite handy. To be a PDF, one of the conditions is that none of the values of f of x are less than 0 for the whole domain of the function, so it's quite handy. As we go to graph mode, we're going to plot this, so it is minus 0.2 x squared times x minus the cube root of 30, cube root of 30 and to plot that over the domain, and we're going to have a look at it. And actually I've kind of been messing about with my domain anyway. If not, just logically, your probability density functions, you could probably have a max of 1 on that, and for this we know it didn't go less than 0, and we knew that b, we don't want to look at it beyond cube root of 30, so actually I don't need this negative bit, but I'm okay with that. I just need to find an integral, so I'm going to do shift G solve, and I'm looking for an integral at dx, and then we just need the lower bound that we know is 0. The upper bound is the cube root of 30, so actually it's a bit different when you're putting it into the graph bit, so I'm going to press 3. That should give me a cube root of 30, I hope. And then, yes, it looks good. It looks good because I knew the 0 was cube root of 30, so we've got those in. And that gives us a value, remember, to 3 significant figures. The mean equals 1.55. But given that I'm going to use this again when I calculate the variance, so that can be my answer, but I might just log. I've never really used memory buttons, so I'm just going to write the long number down. 1.5536 1625. Right, part C, we need to find the variance. So the variance of x is, it's the expected value of x squared times f of x dx between b and a, minus the mean squares. So it's the mean of the squares, the expected value of the squares, minus the square of the mean. So that would be, well, if we try and work this out using a calculator, so that's going to be equals the integral between the cube root of 30 and 0 of, well, if you just look at what happened when we times it by x, we got this 0.2 x squared, so really we just need to change it to x cubed. So minus 0.2 x cubed times x minus the cube root of 30, so it's all of that minus 1.55 squared, so that should give us our variance. So we should be able to go to our calculator, and actually most of the work should be done to us, so hopefully we can just change that value, just change the x squared to an x cubed. So if we go back out, go into this, and hopefully we can find this x squared, change it to an x cubed, draw it, Looks okay. We can see the whole thing, so then we just do the integral again. So shift G solve, find the integral. Integral with respect to x. Lower bound is still 0. The upper bound is still the cube root of 30. So that is 3 cube root of 30. And looks good. And that gives us 2.8964 6815 minus, so our 1.55 can be 1.55361625, and don't forget to square the mean. Remember, it's the mean of the squares minus the square of the mean. So therefore just go to the main screen of the calculator, and we're going to have 2.8964 6815 minus 1.5536 1625, and then we're going to square it, and that gives us an answer of 0.48323 SF. That is our variance, mean of the squares minus the square of the mean.